everyone, this video is about numerical solutions of equations. First of all, the difference between analytical and numerical. So if we have to solve x equals minus x plus 14, of course the x is 7, simple. We can do this by hand. So even if we have trigonometric equation or logarithmic or whatever equation, if we can do it by hand or we can do it effectively, and we don't have to try or use computer or use calculator, then that's questions that can be done analytically. But for this kind of questions, for example, x equals sine x ln x, we cannot find the answer by hand or manually. We have to use a calculator, or we have to somehow try out the solution. Like for example, we try if x is 1, will it satisfy this equation, or maybe the x is 0.5, will it satisfy the equation, and maybe 0.6, 0.7, and we try all the possible numbers. So if we want to get the answer correct to 10 significant figures, it'll take forever, of course. So in this section, numerical solution of equations, we are discussing how we can get the answer using the calculator. So first of all, set the angle to radian and plug in sine 1 minus ln 1 equals, see what you get, and then sine answer. So you don't have to put in the sine function again. You can just like go back and replace the 1 with the answer button, this one with the answer button, hit equal sign, and then you get the second approximation, and you can hit the equal sign 100 times. This is an exaggeration. You can just keep pressing until the displayed number doesn't change anymore, and you will get this value. So this is correct to 10 significant figures. So this section is all about finding this kind of approximation of an equation that cannot be solved using the usual analytical method. Intersection versus solution. So the solution to x squared plus x minus 6 equals 0 are the x coordinates of the intersections of, so if we have y equals x squared minus x and y equals 6, if we want to find the intersection, we do x squared minus x equals 6, and for the x squared minus x minus 10 equals minus 4 and so on. And of course, if we simplify, we get this. So the solution to this quadratic equation is actually equal to the intersection of the two functions here. So if we have y equals x squared minus x minus 6, the red curve, the the x-intercept when the y equals 0 is of course x squared minus x minus 6 equals 0. We get the solution minus 2 and 3. And if we find the solution to x squared minus x equals 6, the intersection between these two functions, the curve and the straight line, we also get minus 2 and 3, because x squared minus x equals 6 is exactly the same as this equation here. So test of sign change now. So let's say we have this function and we want to find the root or if this is the root, it's around 4 and 5. So of course, if we plug in the x value 4, we will get something positive, and if we plug in 5, we will get something negative. So the concept is if when you plug in some x value, you get something positive, and then you plug in another x value, you get something negative. So positive, negative, we have a sign change, then the root exists between 4 and 5. So it can be positive to negative, negative to positive. We have different signs than root exists. For example, given f of x equals 0, root exists between x equals a and x equals b if f of a and f of b have opposite signs, plus and minus or minus and plus. Notice that we are using small f here. So for example, show that e to the x minus x minus 2 equals 0 has a root between 1.1 and 1.2. So the f of x is e to the x minus 2, because it's the function something equals 0. So this is the f of x. You plug in 1.1, plug in 1.2, and you'll get something negative, something positive. We have a sign change, so the root exists. Another type of example: show that the line y equals x meets the curve y equals ln x plus 2 when the x value is between 1.1 and 1.2. Same thing. So when you find the intersection, meets, so we are finding the intersection, x equals ln x plus 2. If we move everything to the left, we get something equals 0. So this is the f of x. You plug in 1.1, plug in 1.2, you should get minus this plus this, sign change, so the root exists. The initial estimation, when given two values with confirmed sign change, just use the average. That's the fastest way you can find the the root usually. So for example, if the root exists between 4 and 5, then use 4.5 for the initial estimate. Between 1.1 and 1.2, between 1.1 and 1.2 again. So from the previous examples, we use the mid value or the average. But when we are given graphs such as this, we have green graph, red graph, just read the graph. If it's around 7, then we use 7 as the initial estimate. Iteration, use x equals something. We can use the value of that f of x as the new x value, and we can repeat the process and improve our approximation. Notice that we are using capital F here, big F. If the values approach a certain limit, we say the iteration converges. So for example, x equals ln x plus 2, and the root between 1.1 and 1.2, the previous example, we use the initial estimate 1.15, the average. You plug in 1.15, see what you get, and then you use your answer, plug in again ln this plus 2. So it's like a loop here. You keep repeating the process. That's why it's better to use the answer button in the calculator. And if you keep repeating, you will get this value in the end. It doesn't change anymore. It converges. Converges means the displayed number in your calculator doesn't change anymore when you press the equal sign. Finding the iterative formula. So for example, here x squared plus x minus 1 equals sin x. If you rearrange into this iterative formula does not converge, or if you use this, also does not converge. But if you use this, it does converge. But in the paper 3 exam, you don't have to really know which formula you have to use because it will be given. What to write and when to stop. So let's say this is the iterative formula. Between this and this, correct to 5 decimal places, showing in 7 decimal places. So we use the initial estimate, the midpoint, and you put the 0.95 here and here, you get 0.9292015, and you keep using the answer button, press equal sign, and so on. So you have to write in 7 decimal places, so be careful when rounding off, and just look at the result when you round off. Remember, in 5 decimal places you have to get exactly the same value, so we can just use 3 exactly the same values for us to draw the conclusion that the answer must be this number in 5 decimal places. And you can just press the equal sign until the number doesn't change anymore, just to check whether your approximation is right, or to check that it converges. So in conclusion, from any equations including g of x equals h of x, you can rearrange to small f of x equals 0, something equals 0, and then you use this function to check for the test of sign change, and you can rearrange to x equals something to find the iterative formula. And in each step, check the rounded off value, correct to the requested degree of accuracy. That's it. I'll see you again next time.